Once more, in this lesson, I'll be repeating the last sequence or the equation of the quadratic sequence that I have done in the previous video, but this time I'll be using a different method. If you didn't understand the method of simultaneous, you can skip it and listen to this one. Now the sequence, to write it nicely, is 1, 4, 9, 16. Now in this lesson, I'm gonna make things simple for you. Let's do it this way. Right. So what I'm going to do, we're going to look for the first differences just as we have done in the previous video. We're gonna say 4 minus 1, it gives us 3. We're gonna say 9 minus 4 gives us 5, and we're gonna say 16 minus 9 gives us 7. And these are our first difference. Up to so far, everything is the same. Now, on the first differences, these ones, I'm going to come with the second differences. Now, what I'm gonna do, I'm gonna say 5 minus 3 is gonna give me 2. And I'm gonna say 7 minus 5 and it's gonna give me 2 again. And we can still notice that the second difference is constant, meaning it remains the same throughout. Please don't forget that a quadratic sequence has the second difference being constant, whereas the arithmetic sequence has the first differences being constant. Now here, what I want to do here, if you don't understand, just note this, that on the first differences, you're gonna say 3a plus b. On the second differences, you're going to say 2a. And on the given sequence, which is this one, you're gonna say a plus b plus c. Now here, what I want to highlight that is very important is that a plus b plus c is equal to the first term of the given sequence. This means that the given sequence in this case is 1, 4, 9, 16. So a plus b plus c is equal to 1. This is the first term in the sequence that is given. 3a plus b is equal to the first term of the first differences. This means that 3a plus b is equal to 3. 2a is equal to the second differences. 2a is equal to the second difference. We have done this even in the simultaneous method. The only difference is that this case we're not going to solve using simultaneous. We're going to say that a plus b plus c is equal to the first term of the given sequence, and then 3a plus b is equal to the first term of the first differences, and then 2a is equal to the second differences. Awesome. Let's continue. So we're going to start. We know that it doesn't change. The general term, the nth term, or the defining equation is that Tn is equal to an squared plus bn plus c. Now, this means that we're going to solve for 2a. We're going to say that 2a is equal to 2. That is the first differences. And then a is equal to 1. We're going to plug a in the first, in this formula. This means that Tn is equal to 1 times n squared. It's going to be n squared. And then we're going to say plus bn plus c. Then we are going to say that 3a plus b is equal to the first term of the first differences. This means it's equal to 3. 3a plus b is equal to 3 in this case. 3a plus b is equal to 3. Now our a was 1, so we're going to plug 1 in here. Then plus b is equal to 3. Now we can say that 3 plus b is equal to 3. And then b is equal to 3 minus 3, which is equal to 0. That's why in the previous video I've said there's no value of b. Then in this one, we're going to say that a plus b plus c is equal to the first term in the given sequence of 1, 4, 9, 16. This means a plus b plus c is equal to 1. Our a was given as 1. Our b, we do not know, we know it as 0. Our c, we are solving for it, then is equal to 1. Then we can say that c is equal to 1 minus 1. This is equal to 0. Now, we can go back to our equation and plug all the values which we have calculated. We have said that Tn is equal to n squared, because a is equal to 1. B is 0, you can say 0n, plus c, which is 0. Then our formula becomes Tn is equal to n squared. We know that 0 times n is 0 plus 0, which remains as n squared. So we can leave it here. So now you can compare the two videos. You will see that we have found the same answers. If you're not comfortable with the idea of simultaneous equation, you can look at this video. What I want to stretch here, that is very important, is that when you are here, you must not forget that a plus b plus c is equal to 1. 3a plus b is equal to 3. 2a is equal to 2. If you don't understand what's going on here, I urge you just to cram this. 2a is equal to 2. You must know that 2a is equal to the second differences. 3a plus b is equal to the first term of the first differences. And then a plus b plus c is equal to 1. Thank you for watching. Bye bye.